Okay, when we talk about the hazard, we talked a lot about so many hazards, risks, and we said the hazard, whenever there is a hazard, there is a risk. In order to eliminate the risk, so your system will be safe to a certain point, you control the hazard in a proper way, or you just eliminate the hazard if you can. But in real life, sometimes no, there is a hazard and I cannot eliminate it because it's portion of the process. So I have to find a way to control it and I have to stay safe. Okay. A hazard is something that might hurt you or the company, or it might damage, other machines, equipments, production line, just name it. So it is not just something that hurts you. Okay, anything that might hurt other things, we call it a hazard. Okay. When I talk about a hazard, sometimes I can identify the hazard. Okay, good. That's an easy situation. Sometimes no, I cannot identify the hazard. Then I have to do some analysis. Okay, some analysis. And by identifying the hazard, what I'm doing, basically, I am preventing accidents. And this is very important. So the whole idea of identifying a hazard, okay, eliminating it or controlling it, is to reduce a risky situation. So we go back to here. We have two types of hazard. We have analysis. We have two types of hazard analysis. We have a detailed hazard analysis and we have preliminary hazard analysis. Okay, what's the difference? The difference, guys, as you know, whenever we want to go into details, that means it is something big. Okay, something big. Whenever there is something major, big, critical, I have to go into details. Whenever something is not that critical, I will do, little bit of checking things out here and there. And this is usually common in our life. In safety, whenever there is something very critical, I have to do some detailed analysis. Okay, if something not critical, and we are gonna discuss what do I mean by non-critical, we'll do something we call it a preliminary hazard analysis, and the abbreviation of it we call PHA. PHA, preliminary hazard analysis. Okay, when I need to conduct such kind of analysis, we need it to identify potential hazards. Okay, potential hazards. There is a potential that this is a hazard to the maintenance guys, to the employees, to the workers. So if there is a potential, I have to do preliminary hazard analysis, PHA. And also the advantage of it, I can prioritize, the hazards. This is more important to fix than the other ones, okay? Because some of the hazards are, less probability to occur. So this is the advantage of this preliminary hazards. Now the question is, when I talk about preliminary, when should I apply it? Okay. Why don't I apply a detailed hazard analysis right away? Well, I do not apply detailed hazard right away unless under certain circumstances. We'll discuss them later on, because detailed one will require more time, more efforts, more statistics. You have to gather more information, and anything takes time usually. That means also it takes lots of resources, including cost factor has to be considered. So while the preliminary one might solve the problem in the beginning, and could be a quick solution. And that's what we are going to see in the upcoming slides. So if I take a look at the preliminary hazard analysis, the PHA, okay, one of the reasons they mention here, hey, you know what? Detailed one is going to take time, and I have to make a call whether I can use this machine or not. Okay, if I cannot use that machine, therefore, you stop it. Okay, you stop it. That's a hazard. Kill the production. Yeah, but I lose. Maybe I might lose. Hundreds of thousands of dollars. So what should I do? We say, hey, let's do preliminary hazard analysis. Okay, and this will require less time, okay, and less cost, and it's gonna give me a prediction whether this is a hazard situation or not. Okay, especially if it's a new equipment or a new task for some workers, maintenance guys, and just name it. So this is a quick solution, and that's why they said it can serve as a guide for a future detailed analysis. Okay, it's a good indicator for us. Another thing here we're gonna consider, and I mentioned this in the previous session, always when it comes to hazard, we have to use the concept of cost-benefit approach. Okay, it is a utilitarian approach. Every hazard, has its good side and bad side. When I say good side, is it is a hazard, but I needed, let's say, to do certain jobs. Like a very simple example would be electricity. Electricity is hazard. It's a hazard by itself. But I can control it. I can reduce the risks. I can find the proper remedies. So why should I just eliminate the hazard? Okay. The benefit of this electricity is more than the cost. What are the costs? Hey, follow certain standards, procedures, have good, let's say, grounding, earth ground, have good circuit breakers, up to the code, and just name it. And by that, I can use the electricity with very minimum acceptable risks. Okay, so here, this is cost benefit approach. In hazard analysis, we apply the same thing. You cannot tell me we have to stop a production because a guy had a paper cut. He was holding a paper, brand new paper, and he cut his finger with that paper with minor injury. I will tell the guy who is ordering to shut down the production, hey, cost benefit approach is telling me you are wrong. The cost is way more than the benefit here. Okay, because this is a very minor incident. It's not happening a lot. The consequences of this event or incident is it's almost nothing. So you cannot just stop the production line. So the solution here is not acceptable. Okay, and this is very important, guys, in our even daily lives. So this is a situation here. Now the second question would be when I'm gonna use detailed analysis and what kind of methodologies I have to use. Well, based on what we said before, in cases where the potential exists for serious injuries, not minor one, okay, or not serious but multiple injuries, it's very frequent that someone is hurting himself with minor injuries, okay, Or we have a catastrophe, like what? Like coronavirus, COVID-19 outbreak, okay? Then I have to apply a detailed hazard analysis. I have to know the root cause of the problem so I can eliminate the risk. I cannot just use assumptions. In order to know the root cause and the proper, procedures to follow, we have to use certain analysis. And those certain analysis methodologies, sometimes they have to do with the operator, some others they deal with the machine, and so forth. And they summarize them into categories. So the first one we call it failure mode and effects analysis. Okay, failure mode and effects analysis. Okay, we're gonna go into those into more details in a bit. The other one we call it FTA. Okay, fault tree analysis. Then we have hazard and HAZOP analysis. We have the HEA analysis, human error analysis, risk analysis, and the TAR analysis, which is a technique of operation review. Let's go over the first one. Okay, over the first one, which is what? Failure mode and effect analysis. Okay, what's this about, and when do we need it? The FMEA, okay, typically focuses on the system, So that's why we say, hey, examine the system, divide the system into various components, check every component to make sure, hey, to check where is the hazard, okay? And it can give every component from a scale from 0 to 4. And based on that, I can know which one is more hazardous than the other. And I can check where is the potential failure, because sometimes this kind of failing, okay, the failure of those components or one of those components might affect my operation. But this here is dealing with the machine, or also eventually might affect the human, being, the operator. So this kind of analysis, it's limited. Why? Because it focuses only on the component, okay, of a given system. Okay, that's a problem, because what's missing? It's missing the element of a human error. Okay, there could be a human error. Could be an operator overloaded the machine, and in a very in a very bad, aggressive way, and it was on purpose. So this is a problem. Okay, or no, we did not pay attention that the operator might do the sequence of apply the sequence of operation this way. So that's why we say failure mode and effects analysis is limited, when it comes to human error, and it's more into what? Into the system. The second one we have to discuss is the hazard and the operability review, which we call it HAZOP. Okay. Also, this has good, good side, and it is limited in some other, dimensions. So, what's the advantage of this? This is designed and developed for what? For use with the new processes in the chemical industry. Okay, so it allows problems to be identified before a body of experience has been developed for a process or system. Can you think of any limitation of this analysis? So the idea of this, method or analysis, okay, I go over the process before I start, my, let's say, production. There is a process. I have to check it, especially if it's a chemical process. Okay. So I will check it. I will have a team to check this, analyze it, and give me the proper procedures that I have to follow. And that's why they say here, consists of forming a team of experienced, knowledgeable people from backgrounds relating to the process or system, and having team members brainstorm about potential hazards. So I take this process, I get this team, okay, and I tell them, hey, study what could be a potential hazard before I start using it, okay? So, because as you know, in a process, so many factors might start popping up. So I have to be careful. I have to get the proper potential hazards in order to eliminate that or control it. And that's why they say here, okay, quickly, in when they discuss a step-by-step manner, what do they say? Okay, we select the process that we want to study or analyze. Then we have the proper team with good experience, good background, okay, to get involved. Then I go, with the procedures. This team starts studying it, analyzing it, and give me the summary, whether it is good, bad, what should I do, what should I not do. And the problem with this review is, it predicts, it's only to predict, what could happen, okay? So it does not also go into more details. So it's not like the FMEA method, okay? And does not take into consideration, directly the human error. No, it predicts what could a human do wrongly, okay, and how to prevent it. So I do not go study, the machine itself or the human himself or herself. Is that clear? So it is more into the process, and I predict what could happen, okay? And this is also important. The other one is, no, it has nothing to do with the system, okay, and the components of the system. It has nothing to do with the process itself, okay, and what could happen because of it. This one here, the HEA, human error analysis, it has to do with the human himself, okay. The center of the study is the human error, okay, the human error, not the process. So the human error analysis, okay, is used to predict the human error, okay. So it has nothing to do with reviewing what has occurred. So I use it to protect the human from, doing something wrong, okay. So it's more into the human. It is not about the process itself, okay. It's about how the human is gonna behave into more details, okay. The process might include some human errors, but the whole concept of the process is the whole purpose of the previous one, which is, we call it a hazard, okay. It has to do with the process itself. You might have in it maybe a human factor, okay, but it has to deal with the process, as a completed process. The FMEA, if you go back to it, the job of it is to tell me, hey, where I might have a failure in the system, in which component, okay? The FMEA is to tell me, hey, where I'm having, or where, I might have a failure in one of the components of my system. Then we move to the second one, which we call it hazard. And this one here, what does it do? I'm sorry. Okay, here. What does the hazard do? It is to deal with the process. Okay, to deal with the process. Okay. Uh, hazard and operability. So I'm dealing with the operation here. I'm not dealing with the human. I'm more focused into the operation. Okay, developed for use with the new process in the chemical industry. It allows a problem to be identified before a body of experience has been developed for a process or a system, because a system has a process in order to operate it. Then we moved on to the third one, I'm sorry, which we call it a human error analysis. From the title, you can tell here our center, our focus, okay, our major point to study is a human error, okay. I have to predict how a human error could occur in order to prevent this in the future. It's like when you write a program, okay, you write a program, you have to make sure when you write a program, you have you have to think about all the scenarios, so no one by mistake might delete a data, might override certain files. Isn't that what we do? Or when you have you develop a bicycle, let's say, okay, someone is gonna ride this bicycle. The first thing you are gonna say, hey, if I'm going very fast, riding it very fast, how I'm gonna stop the bicycle? So basically, or how I'm gonna prevent an error done by a human being, okay, if he start going faster or he is doing weird things. So here I look at the human error factors. Example in automation or in real life example, production. Okay, you have a good system and you have a robot. Okay, there is an operator feeding the robot. The robot takes the part from that operator and start, let's say, welding it, or picks it from the station close to the operator and put it in another station. Right away you are gonna ask yourself, hey, what if the operator by mistake was in the way of the robot? What could happen? Okay, how I'm gonna prevent that human from going into that scenario? This is a potential hazard, isn't it? It is. So you might tell me, hey, here we have a process. Yeah, but also we have a human error, because maybe by mistake that human being, the operator, was overloaded, was stressed. He did not pay attention to certain rules, so he did not follow the sequence of the operation. He did something a little bit off, or the the outlines of the proper procedures. So how I'm gonna protect him? And that's why we add a fence. We have safety, safety situations, and etc. So the HEA should be used to identify hazards before an accident happen. And what kind of accident, based on what those accident will happen, because there is a human error. Okay, a human error by mistake. We have two approaches to HEA, human error analysis, to be effective. The first one, we can observe the employees. So this is very important. In the previous one, the hazard, we said we predict. When I do the process, we predict. Here, no, I can use this while the operator, is doing his job. So it's not just before I start implementing the process. No, while I'm doing my job, I come in and double check, is this operator, the worker, safe 100% or to a certain point or not? Okay, is there any hazard situation? Is there any hazard or not? So that's why what they are saying, observing employees at work and nothing, hazards. The task analysis approach. So here I'm using one of those approaches. I'm monitoring the worker. I can even record, the way he is dealing with my machine, the way he is implementing my process. Okay, while the hazard, no, what does it do? We do it before I implement the process, and I can predict potential hazard. The second situation, in order to make the HEA effective, actually performing a job task to get first-hand feel for hazard. Okay? Performing a job task to get a first-hand feel for hazard. If I'm doing the job, okay, if I'm doing a job, I can tell, hey, oh, we have lots of noise. Oh, this robot is very close to my finger, to my body. Or I need, taller, fans. I need to install, a safety light curtain. I need to have a safety mat. I need to have an e-stop. So all this, I can do it from the first job. Before I make it standard, I can tell, hey, based on my first run, hey, we have issues here, be careful about it. So it is a good idea, based on what I'm talking about, is a good idea to have three things together. The FMEA, the hazard, because it can check and predict potential hazard through the process. And then also, I can monitor my worker while he is implementing the process and doing his job and see if there is any hazard. And by that, I can reduce the risk and I have better understanding, of my hazards in the company. So the last one will be the TOR, technique of operations review. This usually, when do we apply it? We apply it after a failure happen, after the problem happens, the incidents happen. So we use it. So the supervisors, the employees, anyone who is involved, in that situation, they sit together and they start asking certain questions and to review the details to answer a very simple question. Why this happened, okay, and what should we do not to allow it? And that's what we say here, TAR is triggered by an incident. After the incident occurred, I use it. While the previous ones, no, it's more, you apply them like FMEA, I don't have to wait for this failure to happen, for this failure or that failure to happen. For the hazard, no, I do it ahead of time, before the process. For a human error, I can do it before or while, the operator is doing his job. But for this here, the last one, the TAR, it's triggered after the incident has happened. And then I go do my study analysis and see, where are the weaknesses and where is the strength.